Welcome back, everyone. In this lecture, we're going to go over creating and training the model for our project. Let's head to the notebook and get started. Okay, here I am under creating the model section of our exercise notebook. We'll go ahead and run this cell to run the imports necessary, specifically sequential and dense. And optionally, you can add in dropout layers that we went over during the classification lecture of this section of the course. So you have a lot of flexibility here over the number of layers and neurons you want. We're going to follow a pretty simple approach here, where if we take a look at XTrain's shape, it starts off with 78 features. So what I'm going to do is have my first layer match that. We will say model.add, dense, and it's a pretty good rule of thumb that your very first layer should probably match the same number of features for just a normal artificial neural network. And then the activation function we will choose is rectified linear unit. And then to try to help prevent overfitting, we will go ahead and add in a dropout layer. And this is something you can play around with as far as the dropout rate, but I'll go ahead and just do 20% here. And then I'm going to copy this and add in a couple more hidden layers. But what I'm going to do is I'm essentially going to reduce the number of neurons about in half for each layer. So we'll go from 78 to 39, and then from 39 to 19. And we'll have dropouts on each of those layers. And then, this is the layers that you do need to match up for, is the output layer. Recall, we're really just performing binary classification, which means we should have one neuron at the very end. So one dense neuron, so units is equal to 1, and it should be using a sigmoid activation function. So recall the sigmoid activation function pushes values to be between 0 and 1. And next what we're going to do is we will compile the model, and this is also where you need to match up. So because we're performing a binary classification, the loss should be binary underscore cross entropy. And then after that, we'll go ahead and choose our optimizer, and I'll choose Atom for my optimizer. Go ahead and run that cell and make sure it compiles. And then what's next is we need to fit the model. Here you have a lot of options, and if you wanted to, you could also add in things like early stopping, but I will go ahead and just fit the model for 25 epochs. So we first pass in our training data, so we'll say XTrain and YTrain, and we'll say epochs is equal to 25. Now because this is a much larger data set, it's probably a good idea to feed this in batches. So as recommended by the task, we'll say batch size is equal to 256. And then finally, we also want to pass in our validation data so we can plot out the losses and see if we're overfitting anywhere. So we'll pass in X-test and Y-test during the actual fit call. So if we go ahead and run this, let me clear the old running, and let me run this guy, make sure we don't get any errors, and there we go. So I'm going to essentially end it here, and in the very next lecture what we're going to do is after this is done training, we're going to move on to evaluating model performance. And again, if you're on a slower computer or you're running this on Google Cloud, you can always choose less epochs, choose a larger batch size, or just eliminate batch size. However, this is enough samples where you should really be feeding it into batches. And the other thing you can do is if this is taking too long to train, is as mentioned before, you can actually, before normalizing and before doing train test split, just use df.sample to take a sample fraction of the entire data set, since we are dealing with quite a large data set. Okay, so this is currently training. I will see you in the next lecture where we begin evaluating this model's performance.